Welcome. In this class we are going to see how to find the shear force diagram and bending moment diagram of the beams. So let's begin with how to find the shear force diagram of beams. Now here we have a simply supported beam and we are asked to find the shear force diagram and bending moment diagram. So always to find the shear force diagram or bending moment diagrams, the first step is always find the support reactions. Okay. Now you can see we have two supports here. Therefore, this support is pin support. Here will be two reactions. RA is a vertical and let us denote RAX as a horizontal reaction at pin A, and B is a roller support, so here is only going to be one reaction. Okay, now to find the support reactions we have to apply the equilibrium equations. Let this direction be x direction, that is along the span of the beam is x-axis, and perpendicular to the span of beam or parallel to the support reactions and the load is y-axis. Now the first step is apply the equilibrium conditions. What are these? They are summation fx equal to 0, summation fy equal to 0, and summation of moment equal to 0. Now let's apply first summation fx equal to 0. Summation fx, x is in the direction of span of the beam, right? Now in the span of the beam there is only rax, only one reaction, and there is no other force in the direction of span of the beam or in the x direction, so we can say rax equal to 0, right? Now since rax equal to 0, I am just going to erase this because we don't need it. Now let's now apply summation of fy equal to 0. Now fy, y-axis is in the perpendicular direction of this beam, and parallel to y-axis you can see rb is parallel to y-axis, so it will be included, reaction at b will be included in this summation fy, right? Ra is also, and this 6 kilonewton per meter is a UDL, which is of course in the vertical direction. So we can say, let us assume the upward forces, okay, the upward forces as positive and downward forces as negative. You can also do the vice versa, but whatever the sign convention you choose, you have to choose it right from the beginning until and till you find the shear force diagram or the bending moment diagram. Okay, now ra and rb, they are upwards, you can see, so I'm going to use them as positive sign, so I can write. Now let's sum up all the forces, all the upward forces. Upward force is ra plus rb is also upward forces. Now this udl is acting downwards, so I'm going to use negative. Now how much is the total load due to this udl? See, 6 kilonewton is per meter, right? And the length of the beam is 8 meters, so how much is the downward force total? 6 kilonewton multiplied by 8, right? 6 multiplied by 8, summation fy equal to 0, so this is equal to 0. Okay, now when you simplify this 6 multiplied by 8 is 48, right? 48. Now let's take 48 to this side, so here it is going to be equal to, okay, let us call this as equation 1. And yes, before I continue, I want to tell you, if you want to download the PDF of this lecture, it's in the description or in the comments. No need to worry about writing, just care about understanding the things. Okay, now we have applied summation fx equal to 0 before. Now we have also applied summation fy equal to 0. Now we are going to apply summation moment equal to 0. Okay, now there are 2 points, moment at a, moment at b. Okay, now let's assume moment at b equal to 0. Now what is moment? We know moment is force multiplied by the perpendicular distance. Okay, now moment at b, we have to consider all the forces to the left of B, which is RA. At B there will be movement due to RA, right? At B there will also be movement due to this UDL. Okay, so let's first apply the movement at B due to RA. Now RA multiplied by distance. How much is RA far from B? 8. So it is going to be RA multiplied by 8, or 8 RA, right? Now again, I have assumed clockwise movements to be positive and anti-clockwise movements to be negative. You can also choose another sign convention like clockwise movements to be negative and anti-clockwise, sorry, it's like this, and anti-clockwise movements to be positive also. Okay, as long as you choose the same sign convention from the beginning till you find the shear force diagram and bending moment diagram, you are good. You cannot change these sign conventions in the middle of the problem. All right, so I have applied 8 RA. I didn't write minus 8 RA. Why? Because RA is going to apply a moment, right? It is going to apply a moment at B like this, means clockwise direction. Okay, now we have 6 kilonewton per meter load, and total load is 6 multiplied by 8, right? I'm going to use minus 6 multiplied by 8, right? This is the total load. Okay, now we can assume, the because this is a distributed load acting uniformly all over the beam, we can assume it to be acting at the center. Okay, at the center. Okay, 6 multiplied by 8, right? This is acting at the center. And how much is the distance? Now we found this load. How much is the distance of this load from B? It is half of 8, right? Because from here to here, A to B is 8, so the midpoint, let the midpoint be C. So from C to B is only 8 by 2, which is 4 meters, right? So 6 multiplied by 8 is the load, right? This is 6 multiplied by 8. This is the load. And how far is it? 4 meters. So load multiplied by distance. So 6 multiplied by 8 multiplied by 4, right? Is there any other load or reaction? No. So this is equal to 0, because summation m equal to 0 is the equation. Let's take this 6 multiplied by 8 multiplied by 4 to the right side. It is going to be equal to, right? Now let me use a calculator. Now 6 multiplied by 8 multiplied by 4 is 192, right? It is 192 kilonewton, right? Now RA is how much? 192 divided by 8, right? So if we write like this, 192 divided by 8, it is 24 kilonewton, right? Basically this is kilonewton meter here. See how? Now see this 6 is what? 6, it is 6 kilonewton per meter, right? This is kilonewton per meter. As you can see here, 6 kilonewton per meter, and 8 is length, right? It is meter, and 4 is again meter, right? So what you get, you cut meter and meter, you get kilonewton meter, right? Now how, why it is kilonewton? Now this 8 is what? 8 is the length, it is basically 8 meter, right? And this is kilonewton meter. Again meter and meter cut, so we only get kilonewton here. Okay, anyways, all of this gave us a reaction at A to be 24 kilonewton. So let me erase this, and remember the value of RA is 24 kilonewton, right? Okay, this is the RA, it is 24 kilonewton, and this is 48 kilonewton. Okay, now from this equation, because this is 24 and this is 48, RA 24 plus RB is equal to 48. Now here we will get RB is equal to 48 kilonewton minus 24 kilonewton, which is again 24 kilonewton. Okay, So we get Ra equal to 24 kilonewton, Rb equal to 24 kilonewton. All right, now we get the reactions. Okay, this is finding the support reactions is always the first step. Okay, now let's begin finding the shear force diagram. Okay, shear force diagram. Shear force diagram is also denoted by SFD. Okay, SFD. Now to draw the shear force diagram, we need to know what is the shear force at A. Actually, we need to know the shear force at each and every point. Okay, from A to B, we need to find the shear force at each and every point. But the shear force at each and every point is going to be very difficult to find, because that would need to find the shear forces at each point individually, right? And that is going to be so much tedious. So what we are going to do, we are going to do two things. Okay, we will find two things. Number one is shear force at important points. Okay, and number two, we are going to find the nature of curve of shear force diagram. Okay, we will not find shear force at all the pointers. We are going to find the shear force at some important points. Now the question is, what are important points? Now we have A, we have C, we have B, and also we have all other points. What are important points? Generally, you should remember that the important points are the support points, the midpoint, and if there is a load at any point. Example, let's say here is a load, another load. Also, we have to find load shear force at this point. Okay, these are basically the critical points or important pointers. Now let's first find the shear force at A. I am denoting the shear force with V. Okay, so VA means shear force at A. Now how much is the shear force at A? Now we know shear force is the vertical force perpendicular to the span of beam, or we can say parallel to the section of the beam, right? So shear force at A, because reaction at A is passing through A, therefore reaction at shear force at A is 24. Okay, shear force at A is RA, and of course RA is 24. Now we get shear force at A. Now let's find the shear force at B. Shear force at B is how much? We don't know yet, because first is we will find the nature of the curve. Okay, this is the first step basically. Okay, I can also write it like this. This is the first step and this is the second step. Okay, so the nature of the curve of shear force diagram, we are going to derive a general equation. Okay, let us say this is 6 kilonewton per meter. Let's assume it to be W. Okay, W is equal to 6 kilonewton per meter, because we have to find a generalizer shear force equation. So I am just assuming to be W. Okay, means rather a generalizer equation. Let us find the shear force at a general distance x from support A, as I am showing. Okay, now is this is the point. Okay, this is any general point at a distance of x from A, and we will find the shear force at this general point. Why? Because it will give us a general equation, and we will see if it is a straight line equation, if it is a cubic equation, if it is a parabolic equation, or what. Right, now let's find the shear force at x distance. Okay, so let me change the color. So shear force at x is equal to, of course, at x, if you look at the left side of the this point, you will see two forces. One is reaction at A, right? This is to the left, and also there is some part of UDL up to this point. Okay, basically it is from x is 0 here, at A x is 0, right? Because x begins from here. Okay, and there is a load, UDL load, from 0 to up to this x distance. This much of part, this part is will also contribute in the shear force at this point. Okay, now shear force at x is what? Shear force at x is due to Ra. Now Ra is upward, means positive, right? Because I have told you upward forces to be positive. That is my assumption. Now from 0 to x, from or A to this point, x point, there is a downward UDL. So I'm going to use negative because it's downwards. Now how much is the load from A to x point? Can you say? Now see, W is per unit, right? Means this is per unit, in unit. Here is 6, 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 right? 6 is everywhere. Now from A to x, how much is the load? Okay, I have by the way, I have also denoted 6 kilonewton as W, right? It is W multiplied by x. W multiplied by x, right? This is a linear equation, right? Because x power 1, the power of x is 1, so it is a linear equation. Or I can also put R is 24 kilonewton and W is 6, right? So this is 6x, right? This is a generalized equation for this beam. This is the generalized shear force equation for this beam, and let us call this as equation 1. Okay, so what we get, the nature, it is a straight line, right? Straight line. Okay, we get the nature of this. Now from this equation we are going to find the shear force at any distance. Okay, example, we already know shear force at A is 24. Actually we don't even need to do this. We can find everything from every shear force at every point using this equation. Let me say how. Now let's find shear force at A, VA. Now at A, what is the value of x? X begins from A, so here at A the value of x is 0, right? So it is 24 minus 6 multiplied by 0, right? This is 0, so therefore at A to be 24 kilonewton, right? And let me write here, this is a straight line, right? Now let's find shear force at C. Shear force at C. Now so you can see how much is x at C. Now C is at the midpoint, total length is 8, so from end to the midpoint is half of 8, which is 8 by 2 is 4. Shear force at C is first is 24 minus 6 multiplied by how much is there, 4. X is 4 at C, right? Now this is 6 multiplied by 4 is 24, right? This is going to be 24, this is 24, 24 minus 24 is 0, right? So we get shear force at C to be 0. Now let's find the shear force at B. How much is the shear force at B? First is 24 minus something, 6 multiplied by x, right? Now 6 multiplied by x. What is the value of x at B? Now x begins from A and 8, so x is 8, right? Because the total length is 8. So I write 8 here. Now this is 6 multiplied by 8 is 48, right? Now 24 minus 48, how much is it? It is minus 24. So we get shear force at B is 24 minus 24 kilonewton, minus 24 kilonewton. Now let's see our checklist. Nature of the curve, straight line, we get this one. Now shear force at important points, we get shear force at A and C and B. We also get this. Now we can safely draw the shear force diagram for this beam. So let's begin. Let me draw some lines here. Okay, all right. Let us draw a, let's also draw a line at the midpoint C and also a line at the B. Let's also draw a baseline. Okay, now this point, this point corresponds to shear force at A. This point corresponds to the shear force at C, and from this point will tell us the shear force at B. Now how much is the shear force at A? You can see shear force at A is 24. So let's draw a line here. 24. So let's draw a line upwards. Why I draw an upward line? Because all the forces above this line are positive and all the forces below this line, this is the baseline, are negative. Because shear force at A is 24, so I am drawing it above this. Okay, and I am assuming it to be 24, right? Because this is the shear force at A is 24, so this much is the height is 24. Now how much is the shear force at C? Is 0, right? So 0 is no line, basically it is just on the base, right? The baseline is 0 line. So at C is like a point. Now at at B the shear force is minus 24. So I am going to draw it below the 0 line or baseline. How much is it? 24. It means the line length here and here is the same, but it is in the downward direction, right? Something like this. Now I have to join all these points. Okay, we get up to this point, here we get the shear force up to this point, and here we get the shear force at this point. Now join these heights. Okay, so here is our shear force diagram. This is positive, right? Because it's above the baseline, and this much is negative. Diagram is telling you that as you move from A to C, right, as you move from A to C, the shear force is decreasing until finally it becomes 0 at C. And when you go from C to B, right, this is B point, right, this is B, so this is B2. When you go from C to B, the shear force again increasing until you reach 24 again. Okay, I didn't write negative my 24, although it is negative. See, the job of this negative is only to tell the direction where should I draw it. Okay, if it is positive, I draw the line upwards. If it is negative, I draw the line downwards. I don't have to write negative here. Okay, anyways, this is the shear force diagram of our beam. Hope you understand this. Now if you want the PDF of this file, okay, don't worry about writing. I have already written all of this in the PDF. Just try to understand right now. Okay, you can download the PDF later on. Don't download it now. When this lecture ends, download the file from the description or in the comments. You will see the PDF link. Just download it from there. Okay, here we go. We found the shear force diagram of this simply supported beam with UDL, right? Now the next step is find the bending moment diagram. Okay, so let me erase all of this. Now let's begin drawing the bending moment diagram for this beam. Here BMD means bending moment diagram. Okay, now again, to draw the bending moment diagram, we need two things. Okay, basically we need the bending moment at every point from A to B, but that is going to be too much long. So what we are going to do, we are going to find the 2 points. Okay, number one is the nature of bending moment diagram curve, and we are also going to find the bending moment at important points. Okay, important points. Now let's first find the nature of bending moment diagram curve, and how we are going to find the nature. Nature means if it is a straight line, if it's a cubic or a parabolic. We need to consider a general section at a distance of x from A, or also we can find this at a distance of x from B. This doesn't make any difference. Now let's find, we have already drawn the section. This is the x. Now let's find the moment at x. Okay, mx means moment at x. Now consider the left part. Okay, moment at x is going to be, there are two loads. Basically there is a reaction at A. Ra is 24, and there is also some load from A to x. These are the only two loads to the left. Okay, so there will be a bending moment at x due to only these two. Okay, now let's first find the moment at, to be the moment at x. We know moment is what? Moment is equal to load multiplied by perpendicular or normal distance, right? This is the formula of finding the moment. Now let's find moment at c due to Ra. So it is 24, again because Ra will induce a clockwise movement, right? At c, sorry, at x, Ra will induce a clockwise movement, so it is going to be positive. So it is going to be Rax, right? Now this down an anti-clockwise moment here, right? So let's denote it by with negative. So I'm going to write here negative. Again, load, how much load from A to x? It is W multiplied by x, right? W multiplied by x. Okay, now W multiplied by x is the total load from A to x, and the total load will, we can assume it to act at the center, because at the center it is going to be the center of gravity. So we can assume this to be here, right? How much is this load? It is Wx, right? This is the load at the center. And how much is the distance of Wx, this load, from x? Now from A to x is x, so from this x by 2, right? So Wx is a load multiplied by perpendicular distance. Perpendicular distance is x by 2, right? So this is Wx, W multiplied by x multiplied by x. So this is going to be Wx square divided by 2, or W by 2 x square. So I'm going to write here W by 2 x square, right? Now which equation is this? Because here is x power 1 and here is x power 2. This, because here is x power 2, this is a parabolic equation. Okay, parabolic. So we found the nature, right? Is parabolic. Now the next step is find the moment at important points, like moment at A, moment at C, moment at B. Okay, now let's find from this equation, the generalized equation. This tells us nature, and we can also find the bending moment at different points using this generalized equation. Now let's find moment at A. Now again RA is 24. I am going to replace RA with 24, and W is 6. This is going to be 6 by 2, and 6 by 2 is how much? 2 ones, 2 threes, right? This is 3 minus 3x square, right? So moment at x is 24x minus 3x square. Now let's find the moment at A. At A, what is the value of x? Now look here. X begins from A, so at A 4 multiplied by 0, right? 0 minus 3 multiplied by 0. Okay, this is 0, this is 0, all of this is 0, right? Now let's find moment at C, the midpoint. Moment at C, what is the value of x? At C is in the midpoint of this span of the beam. Total span is 8 meters. So from A to C is half of 8, which is 4, right? Moment at C means x is equal to 4, right? It is going to be moment at C is equal to 24 multiplied by x. Look at this equation. X is 4 minus 3x square, right? 3x is how much? 4 square, right? How much is this? Now when you solve this, you will get moment at C to be 48 kilonewton. C is how much? 48 kilonewton meter. Now let's find the moment at B. Moment at B is, now this is 24x. Now first of all, what is the value of x at B? X begins from A to B is 8, right? So x is 8 at B, right? X equal to 8. How much is going to be? 24x. 24 multiplied by 8 minus 3 multiplied by 8 square, right? Now if you calculate this, you are going to get 0 again. So again moment at B is 0. Again, we found the nature of the bending moment diagram, which is parabolic, right? We also find the moment at important points, which is at A is 0, C is 48, B is 0. Okay, now at A is how much? 0, right? So I'm going to draw a point here at the baseline because this is a 0 line. Now at C is 48. Now see, 48 is positive, right? Means above the baseline. Let's say this here is 48, okay? Now at B is 0 again. I am going to mark it like this. Now I have to connect these three lines. The equation is parabolic, okay? So there is going to be a parabolic variation, like something like this, and from here it is going to be something like this, okay? And from here to here is 48 kilonewton meter. Now this curve is telling you what? This curve is telling you as you move from A to C, the bending moment is what? Increasing. And as you go from C to B, the bend 0. And from this diagram you can also see the how much is the maximum moment, because here you can see this is the maximum altitude here in this diagram. So the maximum moment M max is where it is located at point C, right? Moment at C, which is 48 kilonewton meter. So here we found the steps of how to find the shear force diagram and bending moment diagram numerically. Now the first step important is nature of the bending moment diagram or the nature of the shear force diagram, and also bending moment or shear force at important point. Once you know the nature and the bending moment at few important or critical moments, or the shear force at few important or critical points, you are going to draw the shear force diagram or bending moment diagram of any beam very easily. And again, I am saying, if you want to download the PDF, it is in the description. And if you have any problems, please contact me. I'm going to the tutorial services. If you want I teach you, please contact me for that. I also offer the one-on-one live online strength of materials or mechanics of material classes to the students. And that's it for today. I hope you enjoyed this class. See you in the next class. Thank you.